Hello everyone and welcome to our channel, Mootechie. A special welcome to all the dairy technologists and students tuning in. This is class 7 in our dairy engineering series, where we continue our discussion on sanitation by diving deeper into the essential equipment used in a dairy plant. In our previous class, we began our discussion on sanitation. Today we will focus specifically on bottle washers, a critical piece of equipment for maintaining hygiene. We will be covering the different types of bottle washers. The three main categories are hand methods, semi-automatic motor-driven brush washers, and fully mechanical washers. Moving on, we will see an illustration of a semi-automatic washer. This type of washer uses a motor-driven brush to clean bottles, representing a step up from manual cleaning, but still requiring some operator involvement. Next, we explore the two main types of mechanical washers. These are the jet type and the soaker type. These fully automated systems are designed for high-volume operations in modern dairies. Now let's look at the jet type washer in more detail. This machine sprays the bottles both inside and out with washing solutions from a series of jets. A typical cycle for a jet washer involves several steps. It starts with a warm water rinse. Next is a hot alkaline solution spray. This is followed by a hot clean water rinse. Finally, the cycle concludes with steam jet sterilization for complete disinfection. Let's discuss the advantages and disadvantages of the jet type washer. Its advantages are that it is simple and very compact. It is also popular in smaller sizes and is lower in cost. However, its main disadvantage is that it is not preferred for large industries due to its lower capacity. Next, we explore the soaker type washer. This machine begins with a loading table that uses a flat chain made of stainless steel. A distribution mechanism then guides the bottles into individual bottle holders. These holders are arranged in groups of 8, 12, or 16 receptacles. A key component is the tipping cradle, which inverts the bottles into an upside-down position. This cradle also includes a safety switch for operational security. This slide shows a detailed diagram of a soaker-type bottle washer. The numbered components from 12 through 19 likely correspond to different zones or stages of the washing cycle, such as pre-rinse, soaking, and rinsing sections. The soaker-type washer operates through a precise multi-stage process. It starts with a pre-rinse at 35 degrees Celsius. Then bottles go through a dormant solution soaking stage. Next, they undergo pressure solution scrubbing at 55 degrees Celsius, followed by outside solution scrubbing, also at 55 degrees. After this, caustic rinsing occurs, which includes inside rinsing at 75 degrees Celsius and outside rinsing. A hot water rinse at 65 degrees comes next. This is followed by a fresh water rinse at 35 degrees. The final stage is a cooling rinse at 15 degrees Celsius. After washing, the bottles are moved to discharge. They are carried in a vertical position by a flat stainless steel belt conveyor. A hood covers the conveyor. An operator uses a magnifying glass for visual inspection to eliminate bottles with minor cracks. This careful inspection helps avoid damage and breakage at later stages of production. The entire washing cycle time typically takes 15 to 20 minutes. Now let's talk about the care and management of these washers. Proper operation is crucial for consistent results. To ensure effective cleaning, all washing solutions must be kept at the proper temperature and concentration. It is important to use the washing powder recommended by the manufacturer. You must keep all jets clean and open to maintain spray pressure. The chain conveyor should be checked to ensure smooth movement. The machine must be run at the correct rate of operation. And finally, you must supply sufficient steam and water for the entire process. This leads us into the important topic of maintenance. Regular upkeep is essential for machine longevity. First, the water valve should be opened and cleaned regularly. The water pressure, which should be between 2.0 and 4.0 kilograms per square centimeter, must be checked. If the pressure is not sufficient, it may be due to clogged jets or a defective pump. Any clogged jet should be cleaned immediately. The pump should be checked for defective shaft seals, clogging, and worn-out parts. The pump strainer, along with the inlet and outlet lines, should be inspected for the accumulation of lime and scale. Maintenance continues with the can washer, which should be cleaned as and when necessary. All the wash sprays, nozzles, and strainers should be checked and cleaned routinely. Most mechanical difficulties in a can washer are caused by a lack of regular and sufficient lubrication, a failure to make adjustments for wear, and not replacing worn-out parts. These problems can be avoided with proper lubrication of all moving parts, timely adjustments for wear, and the immediate replacement of any worn-out components. Our final maintenance points cover operational parameters. The temperature and pressure of the washing solution, hot water, steam, and drying air should always be maintained at their optimum levels. The proper chemical strength of the solution is also a very important factor for effective washing. Heavy scale deposits in can washers are usually the result of inadequate daily cleaning, the use of hard water, and using a solution at an inadequate temperature and strength. These scales can be removed by using an inhibited acid at a temperature of about 50 degrees Celsius. Thank you for joining us for this detailed look at bottle and can washers. We covered the different types of machines, their operating cycles, and the critical practices for their care and maintenance that ensure the highest standards of sanitation in dairy processing. Your understanding of this equipment is fundamental to dairy technology. Thank you. See you in the next class.